Right. Okay. So, right, the recording is now started, so welcome. I will be sending out an email again as a final email with a recording for this and my updated document that I'm going to be working on. I did something similar last year, but with a different approach. So if you want to see that different approach, that is the link to the recording. It was from the webinar of last year, and I'll be doing the webinar later again this year, just before the exams. And that's the link to the document I use. So you can see I did a slightly different approach last time. So what I'm doing this time is looking at I think it's 9 different types of questions they ask that come up every year in some way or the other, and what's at an achieve level, what's at a merit level, and what's at an excellence level, and things to watch out for. So the first thing that's normally the first thing you see when you open the question paper, because it's question 1A, is they ask you to write an solubility equation and a solubility expression. So the difference between a solubility equation and expression is an equation is an equation. Okay, but remember we're talking about chemistry, so it's no equal sign, and you do need to put in the equilibrium arrow. You can't just have that, because that is not an equilibrium arrow, and therefore it'll be marked wrong. Obviously your charges and everything else must be correct. And then the equilibrium expression is when you have to write Ks is equal to, and then be very aware when you write the expression that you use square brackets and not round brackets. And whatever the coefficient is in front of a number, I meant to change that color, in front of a number in the equation gets raised as the power for the expression. So just be aware of that. You need to get both correct in order to get an achieved point. You normally only need about 8 or 9 achieved points to pass, so it's, you should be able to pass. Just as an aside, you should always put in the states in equations. Now you'll notice in the assessment schedule, they have not put in the states. So what I gather from that is it will not be marked as wrong. Sorry, I just think somebody's trying to come in. Um, right, so it will not be marked as wrong if you leave out the state. But otherwise, always try in level 3 to include the state. Okay, so that's normally the first question. You'll notice though last year, the year before last, it wasn't question 2, but otherwise it tends to be the first question that gets asked. And they're simple enough. You are given the formula. So they always give you the formula. So you just need to break it into its ions. So Mg, and you look it up on the periodic table, and on the periodic table you see it's in group 2, so you know it has a valency of 2, so will it have a charge of Mg2 plus? And if Mg is 2 plus and I've got 2 OHs, then it means that each OH must be OH1 minus, because I need 2 of them to balance the positive 2. So even if your formula writing isn't that great, you should be able to write the equation and the expression just by applying a little bit of logic and using the given periodic table. You are also given a resource booklet with a formula in, and we'll come back to that later when we do actual calculations. Right, so those are all the first thing, and it should be an easy achieve point. And I've just got a thing here you can jot down notes to make sure you get that achieve point. Next thing that normally comes up is an achieved level question. Sometimes they gets to merit, often it's just achieved. It depends on what little extra they ask. And that is when you have got a substance a pure substance in water. Now, the way you recognize it is when you are only given one substance and they say in water. Now, if you've got that, then that means this is a simple equation thing, and you can use the formulae that are given in the resource booklet of Ks is equal to S squared and Ks is equal to 4S cubed. So you can only use these formulae when it is a pure substance in water. There's no other substance mentioned at all. Okay. Now, when do you use S squared? When do you use 4S cubed? That depends on the type of salt or solid you're using. If it's a 1-to-1 ratio of what we call an AB salt, so this could be calcium carbonate or um, lead sulfate, okay, because they calcium carbonate or lead sulfate, okay, they 1-to-1. So that's when you use this particular equation. If, however, you've got what we call a A2B salt or an AB2 salt, then we use this equation. So examples here are, say, for instance, silver chromate. Okay, you know it's an A2B simply because this you've got a metal, and it doesn't matter if that's another metal. That means if you've got a metal there, this is the cation and this is the anion. And hopefully you know that silver always has a charge of +1. If you look at the periodic table, you'll always have this diagonal of Ag followed by Zn and then followed by in the diagonal aluminium. So you've got that diagonal. So this is Ag plus when it forms a cation. It's always Zn2 plus if that forms a cation, and it's Al3 plus if aluminium forms a cation. So that's a way of remembering that Ag is always 1 plus when it forms a cation. Right, so if you've got those types of salts, you just simply put that formula in. So this is equal to, of course, Ks. So there's your Ks is equal to 4S cubed. You're told the value is that much, and now you simply solve for S. Now notice what they always write, and I find a lot of students forget this. It's not going to affect your achieved grade, but if you make a mistake and you've just got a mess of numbers, then it will, because this teacher can't follow your marking, because they can't see your correct method because it's just a jumble of numbers. So always say what that S actually stands for. So the S stands for the solubility of, say, the cation or the anion, or in this case, because it's magnesium carbonate, S stands for the cation, and otherwise 2S is for, the B2, the OH2. So does everybody follow what I mean there? Okay, so that's, as I say, normally an achieved level. This is bumped up to merit level because, of course, when the magnesium hydroxide does dissolve that tiny, tiny little bit, then remember you get twice the amount of hydroxide. So if the solubility of magnesium, if you get S equal to that, that's the solubility of magnesium, and therefore the solubility of hydroxide will be twice that amount. Okay, here in the assessment schedule, they've just said 2 times 1.2 times 10 to the 4. Otherwise, you would have an answer of 2.42 times 10 to the minus 4 moles per liter. Right, and then as you can see, you get the same question asked in 2020, but this case, can you see it's one substance in water? So you know you can use this equation of 4S is equal to, sorry, Ks is equal to 4S squared. Here you've got this in water. So again, you can use that. And remember to define what S is. Don't just assume your teacher knows what S is. Here again, you can see you've got a one substance in water. So again, you can use the Ks is equal to 4s cubed. And actually, for the last 4 years, they have not used Ks is equal to s squared, because they do sometimes put that in. Now, here's an example when you don't have a single substance in water. So it's not pure. We've got either a cation from one source and an anion for another source, or perhaps there's a common ion present, or something that's mucking up the calculation that you cannot use Ks is equal to 4s cubed or Ks is equal to s squared, because the cation and the anion aren't in the same ratio as they would be in pure water. So here's an example. You can see I've got my MgO2, but I've also got OH from something else. Okay, and they are now saying I've got to calculate the concentration of Mg2 plus. So we can't say that the concentration of Mg2 plus is equal to twice the concentration of OH minus. We can't say that. We can't use this ratio anymore, because we've also got OH minus coming not just from the MgOH2, we've also got that OH minus coming from NaOH. So here we have to use now our full equation expression calculation, what I call the EEC method. Always make sure you have the equation correct so you can write the correct expression. Okay, it's often given in part A of the same question, but anyway, and only then can you do the calculation. Do not do the calculation until you've got the first two down. Right, so in this particular case, we write down our equation, which we've done, and this is now our expression. So we're at this point, and now we do the calculation. We substitute. So the first thing we do is we substitute for Ks. Now you'll notice there's no Ks given in this question. So if you find something is missing, look, because can you see this is question 2? If you've got, or question 1 something 2, if it's like in part of a part question, then the information can be given in the part 1 of that question. Normally, question A is separate to question B, which is separate to question C within a big question. But if I've got question 1A and 1A, sorry, if I've got question 1A1 and 1A2 and 1A3, then all the information from A1 and A2 may also be needed for A3 and so on. So always look for the rest of the question to see if there's any information. So you substitute that. This is what you've got to calculate. Okay, so you don't know that. You don't know this one, but you need to know the other bits. So you know the KS because you've looked elsewhere in the question. Sorry, it's always slow to change. So you know the KS because you've looked elsewhere. And you should also know this because, of course, in an equation, you can only have one unknown. So how do I know what OH minus is? So the first thing is you look for a concentration, and then you look to see if there's any change in volume, because a change in volume will affect concentration. Because hopefully you know that C is equal to N over V. So I might have had the concentration the same, but then if I change the volume, I'm going to be changing the concentration. So how do I know what's what? So here's a concentration, and we are specifically told that we can ignore the OH minus that comes from the magnesium hydroxide because there's so little of it that we can just ignore it. It's like saying 0.12 plus 0.12 plus 0.00001 is equal to, well, it's 0.1 to 0.01. And if we're rounding to two significant figures, we can just ignore that bit. Okay, that's why they say you can ignore it. Even if we round it to three significant figures, we can still ignore that contribution from the magnesium hydroxide. So we know the concentration of the hydroxide, but we can't substitute it directly into there simply because we've changed the volume. So N is the same because we haven't increased or decreased the hydroxide number of moles, but we have added 30 milliliters of this to a volume that already has 20 moles. So we've nearly doubled the volume. So we've just about halved the concentration, okay, because we've diluted it. We've diluted it by 20 mils. So that is where this figure comes from. 30 mils from the sodium hydroxide divided by the total of 50 mils, which is the new volume. And we square that whole thing, and that gives you an answer. Now notice that this only goes to merit level. So it is quite a big jump from what you did before. Some of these questions do go to excellence level, which is like what we've got in the next one. Please feel free to put into the chat, any question you may have. Now notice how easy it is to achieve, because if you didn't get the right answer, but you generally got something right, like you had the equation and then the expression, and you did substitute, but you may have forgotten the 30 over 50. Okay, you've still got the right idea, although you didn't, improve the or uh, work out the new concentration. So you won't get the final merit point because you didn't get everything right, but you would still have got an achieve point. So from the first one, here's you got your second one. Remember, you only need about 8 or 9. So you're about a quarter of the way there. Or you could have worked out your concentration of hydroxide to substitute in there. So if you got this part right but stuffed up the rest, because say you couldn't work out what the KS was or something, you would have still got an achieve point. Here is though an example of which takes it to excellence level. And this is where you've got to work out when something is going to form a precipitate. And normally for an excellence level, it means there's lots of little tricks in this calculation. So here you've got not only a change in volume because you've got two volumes. So whenever two volumes are given and you're mixing them together, it means you've changed your volume, which means you've changed the concentration. So you're going to have to do that same sort of factor as you did there. And not only that, here they have not told you what the concentration of hydroxide is, as they did in this question up here. They simply told you what the pH is. So you've got to calculate the OH minus concentration of this 40 ml sodium hydroxide solution from the pH. So there are different ways of doing it. You could do it from the pOH. So the pOH is 14 minus 12.8 is equal to, what is it, 1.2, which means therefore the the OH minus concentration is going to be 10 to the minus 1.2, and you can work that out. Or here they've worked it from the other way. So if you're not sure, this is the kW of water, and that is the pH. So they've just used it with the H. And of course, to go from pH to pOH, or to do the hydroxide part, you do need kW. You are given the equation of kW is equal to H3O plus times OH minus. You are given that equation, or the pKW is equal to the pH plus pOH. So I think that one is given, and that's what they've used over here. And basically now what you've got to do is, it's not at equilibrium, so you work out the ionic product. But can you see it's the same sort of expression that you did over there? But instead of saying Ks, which means it's at equilibrium, we just now use ionic product. And you work out its value, and then you compare that value to that one. And 10 to the minus 12 is a heck of a lot smaller than 10 to the minus 5. Do not be fooled by the numbers in front. Don't say, oh, 8.5 is bigger than 7.1. Always look at this part first. 10 to the minus 5 is a lot smaller than, is bigger than 10 to the minus 12. Remember, it's minus 12, so this is 0.00000. It's got to have 12 noughts to it before you get to the 7. I haven't counted my noughts. Whereas here, it's only 0.00. We only have 5 noughts. 1, 2, 3, 4, 5 before we get to the 8. Okay, so that's a lot smaller than that. And therefore, because your ionic product is bigger than your Ks, you are going to get a precipitate. So there's always going to be like 1 or 2 questions based on the more tricky type of solubility. And there'll always be one question on that straightforward achieved level type. Can I use Ks is equal to S squared or Ks is equal to 4S cubed? Right. Then you've got the type of question where you've got to explain. And this is always your excellence level question. So whenever you are given an explanation type question, and you can recognize them because they often say no calculations necessary. So you can see that over here. Okay. Always, however, always, if you're aiming for excellence, put in your equations. Even if they don't ask for equations, can you see that they always give an equation in the answer? Always use an equation, more than one equation. I would also sometimes, because you have to have lots of equations, so always talk about equation 1 and equation 2, so you can say, you know, because this is added, that means that the equilibrium position in equation 1 shifts to the left or shifts to the right, that sort of thing. Okay. Sorry, I've actually missed out a question. Would it make a difference if we times the 2 or not? So yeah, so Anya, that is actually important, but you have to, I presume, and my apologies for not seeing that earlier. I had my wrong screen on there. You do need to, when you're looking at this, if you've got something which is going to give you 2 lots of something, yes, you do need to multiply by 2. Can you see over here? This is twice the amount of that because you've got twice. So if you, the 2 comes up, you know, if you've got in the equation PBBR2 is PB 2 plus 2BR minus, that 2 comes up, that 2 comes up in 2 different places. It comes up as the exponential, and because we've got twice the amount of bromide ions to lead ions, you have to multiply the 2. And yeah, and it'll be the same thing for that too. So any of these sort of things where if the equation has a 2 in it, it appears in the expression, and it appears also in, because you've got double amount of those ions. So let me just go over here. If you've got where's the one with sodium hydroxide? You've got to be careful. You can't multiply by 2 if your sodium hydroxide is coming from a different source to the magnesium hydroxide. So you can't multiply this by 2 because this is not coming from that. This is coming from over here. Does that make sense? So I haven't suddenly made this 0.24. However, I have made this 2 there because I need it in my expression. Does that answer your question? So when you multiply this by 2 or not depends on what you're adding together. If it's coming from something like this, yes, I've got double the amount of hydroxide ions, so I've got to multiply by 2. But if the hydroxide is coming from a separate source, you do not multiply. I don't have double OH minus ions to that. There's no correlation between them. The amount of sodium hydroxide, amount of hydroxide ions has got nothing to do with the amount of magnesium ions because they're from 2 different sources. Okay, I could have tiny amount here and I could have lots over there. Okay. Right, so going back to equilibrium. As always include equations, and as I say, number the equations as 1 and 2. So if you say, if more hydroxide is added, then the equilibrium position of equation 1 is going to shift to the left because of Le Chatelier's principle and, to try and maintain, etc., etc. So it's much easier than that than trying to write out the equation each time, because particularly if you've got lots of equations, it can be quite confusing what equation you mean unless you say identify them as 1 and 2 and 3, etc. Also, when you ever get this type of question, you'll see it's exactly the same thing. Explain using equilibrium principles why whatever decreases, or explain the effect on the solubility. It's always got the same thing because something is added upon addition of something, upon addition. So you've added something. Okay. So when you do these types of questions, always think of 3 things. Common ion. Have I got something sensitive to pH? In other words, something that's going to affect the hydronium ion or the hydroxide ion concentration. So anything like, that's obviously going to be sensitive to it because this is really in a way like the common ion. So a change in pH is going to affect the OH minus concentration. And the last thing you've got to think of is a complex ion. Now, in some questions, it can be all 3 that you need to explain. In others, it may only be 1. In other questions, it may be 2 of them. But always think of all of them. Now, with your complex ions, look at the resource booklet. You are given all the resource, all the complex ions, so there's no excuse not to recognize when a complex ion is formed. So basically, it's the complex ions with hydroxide, with ammonia, with cyanide, and I think those are the 3 main ones. And it lists all the ones where they formed. So make sure you look at the resource booklet. Okay, and so you'll notice it's the same sort of thing. So when you refer to this document, highlight and just see what is needed. Okay, you'll notice they give you they write in the answer all the equations. Now they've given the equations, written it a bit, and then they've written an equation and done anything. Otherwise, you can write all the equations first and go dot, dot, dot. This is equation 1, and you just refer to equation 1. You can go dot, 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 equation 2, and refer to that. But always, as I say, refer to common ion. Is it a common ion or not? And therefore, which way will it affect it? Does a change of pH affect? Is there anything to do with a weak acid, weak base, or a precipitate involving hydroxide? Or is it a complex ion that involves your cyanide, your hydroxide, or your ammonia? Remember also that ammonia is a base. So the moment you put ammonia into water, it does form hydroxide. So there's that little trick as well with ammonia. And you'll notice that over here. When ammonia is added, the Ni are removed. That's interesting, actually. I would have insisted you first say when ammonia is added, if you add a small amount of ammonia, I would have included this one. NH3 plus H2O goes and forms NH4 plus OH minus. So initially, when you add a little bit of ammonia, you are increasing the OH minus. And because you're increasing the OH minus, this is getting more, so the equilibrium position of equation 1 shifts to the left. I would have asked, if I was sitting this exam paper, I would have expected that. Then I would have said, as you add more and more ammonia to the solution, I'm getting now more of this present, and so then I will form that complex ion, and so on. Okay. That could be what the examiners wanted, but there weren't enough people that gave actually that answer. Right, so time is flying. Let's carry on. You'll see they were a little bit tricky over here, and I think that did throw a lot of people. There was a complex ion in 2018 of thiocyanate. Now, though, with the resource booklet, they'll only ask about the complex ions that are given in the resource booklet. So if it's not in the resource booklet, you won't be asked about that, or you shouldn't be. Okay, the resource booklet has only come in the last 2 years, so there has been a slight change in the questions asked because of that. That's why I haven't really gone far back. Really focus a lot on the 2020 paper and the 2021. The others are still very useful, of course, but I've seen a slight change in answers. Now, you will always be asked something about the properties of a weak acid, a weak base, strong acid, strong base, a salt of a strong acid, strong base, or a salt of a weak acid, strong base, or a salt of a weak acid, strong base for the other one. Okay. And you may be asked to give the relative order of the species in solution of all the ions, of all the molecules, depending on what the substance is. Right. If you're doing scholarship, then will they ask? Now, that is an interesting question. It's been a while since I looked at scholarship, Anya. Ask Alison about that, or just simply look at past scholarship papers. Do you know where to find past scholarship papers? Yep. Just have a look at that and see if they've asked anything about that. Because I don't want to put you wrong. So Alison has been looking at the scholarship. I've just sort of been keeping an overview of it, but I haven't been going into detail. So I don't want to put you wrong. Right. So over here, again, can you see the importance of equations? I cannot stress enough, if you're going to be doing any explanation, I want to see an equation. If you're not going to put an equation there whenever it says compare or explain or blah, 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 then you're not going to get excellence and you may not even get merit. So put in your equations. Also note, make sure you've got the correct arrow. If something dissolves completely, then it's completely to the right. So we use that arrow. For anything that doesn't dissolve completely or is a weak acid or is a weak base, then we use the equilibrium arrow. Okay. I don't want to belabor that point because if you look at this document and you look at the answers, you'll see it's the same sort of thing that comes up again and again the way they word it. Notice they clearly state, by the way, the square brackets means concentration of. So if you don't want to say this one is a higher concentration and this lower concentration, and you're always writing out the word concentration, it is a accepted abbreviation to use square brackets. So square brackets are an accepted use in 3 different ways in chemistry. It means concentration of. You need to use them when you draw Lewis structures for ions. Okay, remember when you had a sort of thing here with a Lewis structure, you had to have the ion thing over there. And the last place is in complex ions. So when you wanted to draw, say, a complex ion of copper with ammonia, you would write a square bracket, Cu, round bracket, NH3, round bracket, 4, square bracket, and then the 2 plus. Okay, so those are the 3 different places we use square brackets. Concentration of, Lewis structures, complex ions. Right, and then here's one where they've been helpful and they've actually given you the hydronium ion in here and you had to just fill in the rest for propionic acid. And that, now you might go, oh, I don't know what propanoic acid is if you don't do organic. What I'm going to do, it was given in the question. You can see I missed out like the introduction because I just threw this in here to show the type of question. And again, this is just simply an achieve level if it's just filling in the thing. And you need three of the, well, you need all of those boxes correct because they gave you the H3O plus. So you've got to get them all correct. Okay, so that's all the same type of thing. Look, equations are given, they explain which one is a higher or lower concentration and so on. So I'm not going to harp on much more there because it's the same sort of thing. Let's go down to now the calculations. This is an achieved or merit level question where it's a straightforward type of question. This is like the solubility equivalent, where you've only got a weak acid or a weak base. It's like you've only got that insoluble substance in water. So it's a single substance and nothing else affecting it. So the way you would do it is you will need, remember my EQ method, always do the equation first to make sure you've got the correct expression before you do the calculation. So there's the equation, and because you've got the equation, you will now write the expression, the products divided by the reactants. Now, of course, the water being a liquid, you go. The other thing is, if you've got a Ka, you must have H3O plus in your equation. If you don't have H3O plus in your equation on the right-hand side, don't even start doing a Ka because you cannot make a Ka expression if you do not have H3O plus on the right-hand side. Similarly, for a Kb expression, I mean, we teach via using Ka and Kb. In the exam, they'll never give you the Kb, they'll only give you the Ka. So you'll have to convert by using the Kw to get to the Kb. In the Kb, again, your equation must have on the right-hand side OH minus. If it does not have OH minus on it, you cannot use the Kb. Okay. So as an example of this, if you had, say, a solution of CH3COONA, and they ask you to calculate the pH of this solution, don't go CH3COO minus or Na gives you CH3COO minus plus Na plus, and therefore Ka is equal to CH3COO minus Na plus all over CH3COO Na. Can I do that, or have I just written a whole load of nonsense? Not too sure. I have written a whole load of nonsense because I'm trying to use a Ka expression, and does my equation have on the right hand side an H3O plus? No, it doesn't. I put a Na plus on there. So this is obviously the wrong equation. And so I'm obviously going to have the wrong expression. So always make sure when you write the equation, if you haven't landed up with an H3O plus there, now don't just put an H3O plus there regardless, just because you need it for Ka. Make sure your equation is balanced, because if you've got an H3O plus on the right hand side and your equation is balanced, then you know you're on the right track. Okay. So here now you just simply substitute, because what you've done here, if the pH is that means you can work out this H3O plus concentration. And now it's not put in here, but we assume, and I always say you should actually put in your assumptions, that you assume is equal to that. Because for every one of your propanoic acid, you're forming one of this and one of that. So we're assuming that that will be equal. And that's why we can get the square, because A times A is equal to A squared sort of style. Okay. And this bit over here, you can see is how I get the antilog of this pH to be able to get the hydronium ion concentration. And we are told that my propanoic acid is 0.204. So this is 0.204. They should have substituted. Oh, you've got to show. So you can't, whenever you're asked to show something, you've got to calculate it. So that's why they've done this as an unknown. And you can see they landed up with the right answer. Okay. So sorry, I better rub that out, because you've got to show it, and therefore that's why you've got to calculate it. So that is going to be an achieved and sometimes merit question in 2021. If you had everything correct, you got a merit. Notice also, by the way, try and keep to the right significant figures and make sure you've got units. So because all the values were given to 3 significant figures, give your answer to 3 significant figures, always make sure you've got units. pH doesn't have units. pKa doesn't have units. pKb doesn't have units. And we don't even give units for Ka or Kb, Kw. So they don't have units. So if asked to calculate the Ka, don't put a unit in. However, if you're asked to calculate the concentration of something, that does have a unit of moles per liter. Okay, so here's an example where you are given a substance where you can't just use the substance and dump it into a Ka expression. Because can you see I don't have an H3O plus on there anyway. So what you've got to do is you've got to divide that into your cation and anion and go, which of these is going to react with water? And hopefully you'll know Cl minus comes from the strong acid HCl. So Cl minus will not react with water, because if any Cl minus reacted with water to form your HCl, the HCl, the moment it's formed, is just going to go, I'm a strong acid. By definition, I am going to dissociate completely. So you'll never get an anion of a strong acid reacting with water. Therefore, this has to react with water, and therefore you start always with your equation. I can't emphasize enough, do your equation, which will lead you to the right expression before you do the calculation. And then, as I say, with your calculation, make sure when you're finished, you say, is my answer sensible? Have I got the right significant figures? And have I got my unit? Because can you see if you had everything correct, but you forgot your unit in 2020, they would have dropped you from merit down to achieved. Okay, so these are all, you can see they all go up to merit level. Here again, all up to merit level. Now we get to the titrations. So with the titrations, a lot of those questions that we had before, either the simple ones or the slightly more complex ones, come up around the titration. I've separated them out because sometimes they do give a separate calculation. But here you always will be either given a graph, or you will be asked to draw a graph, or they'll complete part of the graph and you've got to complete the rest. But they'll ask you certain key things about the titration graph. The first thing you need to know is I know straight away that this is a weak acid, strong base type titration. How do I know that? I know that because of that rise in the beginning. I'm starting at a low pH, so I know that in my conical flask, my acid is in here, and I'm adding in my burette my base. Okay, so I'm starting with acid in my conical flask and I'm adding base because I'm starting with a low pH. Then what you've got is another key point that you know is my equivalence point, which is if you drew a line, ding, 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 ding. Now this is obviously not very well done, but if you sort of extended this slope with a ruler on, and you extended this slope on, this difference halfway through, so about halfway to that is round about there, okay? That is your equivalence point. Equivalence. And so that occurs at 25 moles. When I've added exactly 25 moles of sodium hydroxide, I've reached equivalence point, which means my H3O plus is equal to my OH minus. Okay. We pretty much say all my acid has been neutralized by all my base, the other way around. So that's a key thing to know. Also know that you will never get this line going to exactly the pH of your sodium hydroxide. I mean, it will eventually go, I suppose, close enough if you added enough of it. And that's just simply because you've diluted it. Remember, when you've dilute something, because I'm adding this to a liquid over here, a solution over here, then of course it changes the concentration. So as I add my base, the concentration of that, even if I had excess of sodium hydroxide, it'll always be slightly diluted from that acid. So that's why you'll see it'll never go exactly to a line or whatever it's supposed to be from the pH of a 0.163 mole per liter. The other thing you need to know is because I'm adding a weak acid to a strong base to a weak acid, this area over here, this flattish area, is the buffer zone. And the best place for the buffer is when my conjugate acid, so I'm going to call it HA, is its concentration is equal to the conjugate base. And that tends to be the midpoint. If we had exactly the same concentrations of acid and base, it would be exactly like halfway point. But we know it's not exactly the same because we've got 20 ml of acid and 25 ml of base. But pretty much the halfway point over here, at around about 12.5, that is when your pH is equal to your pKa. So if you're ever told to calculate the pKa of something or calculate the Ka of the acid, so here you see you've been given it, but if you needed to calculate it, it is always when you've got your the midpoint of the buffer region. So whenever your H plus, your weak acid concentration is equal to your conjugate anion concentration of that weak acid, and that pH is therefore equal to the pKa. So whatever the pH is, that is your pKa, and you can work out the Ka. So you'll notice this should be 4.87. If I did this correctly at the right place, that should come up to be 4.87. Okay, any questions so far? Right, so here again, notice again, it only goes to type of merit type questions. So these are more complex calculations, but I found what comes up nearly every year was to calculate the pH at equivalence point. So use the graph to try and work out whether your answer is correct. So if you've done a calculation and you've said your answer is 12 point something, look at the graph. And if the equivalence point is not 12 point something, you have stuffed up some way. So you know you should have an answer of around about 8 point something. So if you didn't get that, then you know you may go through your reasoning again. I always just find it surprising when people come up with a very weird answer, and you go, well, there's a graph right there in front of you, and it's obviously not what you got. So um, okay, right. So it's the same sort of thing. Now, notice the way they've done the calculation, because they don't give you the KB. It's different to the way we've taught you. What we've done is we've said, okay, you've got this weak acid of propanoic acid. So you've got your CH3. So basically at your equivalence point, you've really got CH3COO minus and Na plus. So that's like your salt in solution. Now remember, you've got to write either a Ka or a Kb expression. So we can't use that. So we start off with CH3COO minus plus H2O, and you do the CH3COOH plus OH minus. Check that your equation balances. If your equation doesn't balance, you've done the wrong thing. Like if you've landed up with H3O plus on this side because you wanted H3O plus because you wanted to use a Ka, you haven't got a balanced equation. It's not going to work. So you should be able to see straight away, if I've got a negative charge on this side, I should land up with a negative charge on that side, because these two are neutral, so they don't have effect on the charge. So that's one way. If you want to see very quickly, are you going to have H3O plus or OH minus? If I've got a negative here, I must have a negative there. Now that you've written that equation, you know you're going to be using Kb, because a Kb equation must have OH minus on the right-hand side. A Ka has to have H3O plus on the right-hand side. So your Kb is going to be your CH3COOH OH minus all over CH3COO minus. Okay. Now what you would have to do is, because you were given the pKa, remember 14 is equal to pKa plus pKb. So if you know the pKa, you know 14, you can work out pKb, and therefore the K, and therefore the Kb. Okay, and right, so all of these, you'll see it comes up every single year. There's another one, calculate the pH at the equivalence point, and so on. That's because I see it's just about 2 o'clock, so I want to stop there. The other question that we haven't touched on is indicators and buffers. They don't always ask a question on indicators, but they could. So remember, the pKa of the indicator must be within 1 pH unit of the equivalence point. So not of the pKa of the acid or the base, it's got to be within the equivalence point. So we want to basically have this color change happening when we have reached the equivalence point. And that's how you work it out. So this is just all the explanation. You can look it up and see how it works. And then the final thing is buffer. Now, buffer, sometimes there's hardly any questions from it, and other times, like 1.5 questions of the whole paper is on buffers. So make sure you know how to use buffers. Now, there will always be a question to a buffer. Well, I think always. I always use the Henderson-Hasselbalch equation, but you can do it from sort of first principles. But they will always ask you about where's the buffer solution sort of thing. Why is it a buffer? How can it help? So remember, you've always got to talk about the weak acid and its conjugate base ratio. So the fact that if you've got equal amounts of H3O plus, I mean, of the weak acid and its conjugate base, if you add, say, acid, then the conjugate base reacts and so on, and you always sort of keep that ratio constant. It only works for small added volumes of acid and base because eventually you'll flood it, but it will be, help for the initial lot anyway. So look at the type of thing, and then as I say here, there are different ways to approach. In the assessments schedules, they tend to use the basic, the KA type approach each time. So you can look at our modules if you want to use the Henderson-Hasselbalch. So they always sort of start from first principles. So this is like a first principles type thing where they do that. Here again, they've done it from the first principles. So if you want to use the Henderson-Hasselbalch and you get to the same answer, then you're fine. Okay, it's 2 o'clock, so we're going to stop there. I'll just stop the recording.